Okay, now we're going to get into logarithmic functions and tying them to exponential. So looking at the first one, the first definition we've already done here. Y is equal to log base a of x. That can convert to y is equal to a to the x. Anyway, so if we look at these, different inverse properties for logs and natural log. Now, log and natural log is the same thing. Just remember that a natural log is just a log base e. Okay, when I say natural log, anything that we talk about that natural log can do or that log can do, the other one can do as well. So a to the log base a of x is equal to just x. So if you, to a power, okay, so take a number to a power of a log, and that base of the log is the same as that power, then that's equivalent to just 1. And so that's 1 times x, so that's just x. Okay? All right, and then same thing here, log base a of a, those will cancel, giving you just 1, and you can bring that x down. And so x times 1, just x. Same thing goes for, which is more common, what I'm going to use here, because remember, natural log is just log base e, so e to the log base e is 1. Same thing here, log base e of e is 1. So anyway, let's go ahead and solve for y in this case. First thing we want to do, you can go ahead and try this on your own and then come back to the video for practice, because if there's any time that you want to be wrong and be corrected, it's now. So first thing we want to do is get rid of the natural log. So we're going to take e to each side, and when you take e to the natural log, those cancel. But you would have e to the 2t plus 4. 2t plus 4 is in your exponent. And then just to challenge you a little bit, you could also rewrite this as y is equal to e to the 2t times e to the 4. Because remember, when you multiply like bases, you add the exponents. All right, so more properties. Now these properties are when you want to expand or condense or rewrite logarithms in different ways, which is really important. When we go and find derivatives and integrals of these log functions, these rules become really important. So put these in the back of your mind, know where they are, and if you're making a formula sheet, which is a good idea, I would definitely put a lot of these formulas that we're using on there. So on one side you can do everything before calculus, what you should know, and on the other side of the sheet you could do everything that you should know for calculus itself. Okay, so this would be the not so calculus side. Anyway, let's go ahead and solve this one algebraically. First of all, we need to bring that down. So what we're going to do, you either take the log or natural log of each side, doesn't matter. I'm used to natural log, and it's less to right, I guess. Now with this t that was up there, remember the power rule says that you can bring it down and make it a product of the natural log or log. Like this. Solve for t by dividing out that natural log of 1.045, so you'd have the natural log of 2 over the natural log of 1.045. Now these natural logs don't cancel. You have to put in there natural log of 2 divided by the natural log of 1.045, or you could do the natural log of 2 minus 1.045, and that gives you 0.995. So just find the natural log of 0.9 or 0.955, my bad. And that should give you something around 15 3/4. Somewhere around there. So just try it on your own, make sure you're getting the same things. Now we're going to take a look at the change of base formula, and this is important when you're graphing or you're asked to graph or solve. Again, when we go to find derivatives, integrals, stuff like that, you might not be able to integrate or derive this log function, but if you change it, then you can use quotient rules and whatever other rules apply to find the derivative or integral of that one. So again, change of base formula is really important. If we use the change of base formula here to determine domain and range, you wouldn't necessarily have to, but If we rewrite it, it's a little easier to pick apart. You'd have y is equal to the natural log of x plus 1 and over the natural log of 2. And so with your domain, you can see that you cannot have negative values in natural logs or even logs, because this in here cannot be negative. And so you would have then domain has to be from, negative 1, inclusive. It can be negative 1 because you can have 0. So negative 1 to infinity, and then the range can be all reals. There is nothing that prohibits or constricts what the y can or cannot be. So then that means it's all reals. All right, so then that's it. Again, for your toolkit, make sure you're putting in all of these properties for logarithms, the change of base formula, going from a log to an exponent, log base e of x is equal. It's important to know how the natural log fits into this and understanding that it is a logarithm, so anything that we do with the log function we can do with a natural log function.